Hey, you're at Steve Tech. Here we're going to start talking about how to check your bearing clearances properly, what your bearing clearances should be in general, and I'll give you a couple specific illustrations, and how to install your bearings. So one of your first things that you're going to do is you need to have good equipment. You can do this with a plastic gauge, but that is a real easy way of possibly making a mistake and just being too general. So we're going to start checking the first things first. We're going to do the mains. So we are going to check our main journal diameter with a micrometer. Then we actually set the gauge up to what the actual size of the journal is. So you can see here, this is one of our Sudden gauges. We can set that thing up. See right there. We'll move that. So our gauge is now set up to exactly what the crankshaft size is. Now we can go right back over here to where the block is. Now we have installed all the bearings into the block. We've already checked the crankshaft and have determined that the crankshaft is correct size all the way through. But all the bearings are in the mains. Everything is torqued to the proper amount. So now we use the bearing gauge here. Now I'm going to show you some tech here that most people just really don't understand or know. But let me look at the gauge here as we're checking our vertical clearance. So vertical clearance is straight up and down. Vertical clearance. We'll go right here. You can see that this has 2 6/10 clearance right now. All right, but what I wanted to talk to you about, one of the things I want to talk to you about is the bearings in the block and in the connecting rod. We'll show you the connecting rod next, are not round. They're purposely made not round. So this bearing bore, you want to take that out, Dylan? This bearing bore right here is not round. It's made not to be round. None of them are round. No engine bearing in the block or in the connecting rod is ever round, period, ever. Reason being is, as this stretches, we always measure our vertical clearance right here. It's actually bigger right here, bigger at the parting line. It's machined and made into the engine bearing for that reason. And the reason is, as the crankshaft tries to actually get pushed out of the bottom of the block, since it's upside down here, so the cap's trying to push away, this dimension actually gets tight. So it is naturally big. It's machined into the bearing. They are not round. It is actually oval. This would be your tightest spot when it's not running, but as this is running and as it sees more power, this grows like this, which makes this shrink. It's like taking a piece of tubing and crushing it. It gets wider at one end, narrower in the other. Okay, so that is a big deal that people don't understand. Now if we go over to our connecting rod right here, I'll show you that exact same thing. I'm going to show you a couple other things about that, and here it's a little easier to see on the gauge. We'll go all the way around this. Now this is the vertical clearance, and that is at 2.5. See the vertical clearance there? Now we just turn it to a little closer to 108. There you go, a little closer to 90. That would be 90 right there. And you can see that it is actually just under 4.5 at that dimension. That is specifically because as this rod accelerates and actually has cylinder pressure on it, believe it or not, it actually shrinks up that bore, and also shrinks up the bore as the piston goes over top dead center and pulls its way back down. It's always trying to make this housing bore out of round. When it goes out of round, it is always trying to make this tighter, which is also what breaks the rod bolts, if you ever have any problems there. Now, this is a pretty common setup, 2.5 to 3/1000. We'll leave the connecting rods. That's a pretty sweet spot in a steel connecting rod. Big horsepower stuff is usually going to have 2.5 thousandths in that range. You can end up being A little bit tighter on some streetcar type stuff, but we're usually not in that range because we don't build a lot of small horsepower stuff. We'd like to build the bigger stuff. So you're going to be 2.5 on a steel rod. In my Pro Modified stuff, in the like in my SMX engines, with a big billet aluminum rod, and I'll show you this at another time in a different video. Bearing clearances on the rods can get all the way up to 6 to 7 thousandths of clearance and 4 to 5 thousandths clearance on the mains. That's a common setup, but we have a lot of pump there, and the connecting rod is doing a lot of moving around. It gets out around right here a lot. So that 6-7 thousandths of rod clearance is all because the housing bore moves a lot. So we're always trying to keep the bearing alive there. Now I want to show you one other thing here on this video on engine bearing. So that's your general rod clearance, main clearance. Main clearance, we'll probably actually loosen this up to about 3. So we'll juggle bearing shells around so that we'll put an extra thousandths clearance bearing in the block and leave the standard bearing clearance in the cap. So that way we'll get 0.5 thousandths extra vertical clearance right here by actually juggling bearing shells around. So you can have one extra bearing, one under bearing, and then standard bearings, all in order to get that perfect clearance that you would like to have. Now, before we go over to that rod bearing, well, actually, let's do the rod bearing first. Rod bearings. There is a upper and a lower. Understand what's going on. Rod bearings, I'm showing you this rod bearing here. There is a upper and a lower to a rod bearing, unless it's a narrow bearing. You can see here, might be a little tough, you can see a chamfer there. There is not a chamfer there on that side. When we put the improper bearing in the connecting rod, you see there's a connecting rod on this connecting rod right here. There is a chamfer. This goes up against the crankshaft. When the cap's on, that side of the rod goes up to the crankshaft to meet the radius in the crank. If you don't have the right side bearing, upper and lower in there, all of a sudden you won't have any side clearance because the bearing will cram right into the edge there. So you see the distance difference right there? I'll flip that bearing around, put the right bearing in it. Now you can see a whole lot more clearance, all there to fit the cheek of the crankshaft, to fit that radius that's in the crank. All right, so now that is always making sure that you're reading the bearing. It's has a U or a L on it, or if they're an N bearing, which just means that they're narrow, they still need a upper and a lower. And that's also that they just place that bearing in there correctly, so you have ample clearance for your crankshaft radius. Now, what does excessive oil bearing clearance do? Not much, really. What you end up with a lot of bearing clearance is it will make lower oil pressure because primarily it's squirting out right through here. It squirts out in between the rod, it squirts out on the outside cheeks of the rod, and all of this just makes and creates more windage, lowering your oil pressure. If you have enough oil pump, it's not a big deal outside of windage. But like I said, in the big Pro Modified stuff where we have a lot of clearance there, it's throwing a lot of oil around. It just does. In a 1,000 horsepower LS kind of deal, we're going to be, 2.5 thousandths, 3 thousandths on the main, 2 thousandths, 2.5 thousandths on the rod, and that's a good area, makes good oil pressure, controls oil real well. We don't want to get real tight, because as you get really tight on the bearing clearances, it makes excessive heat in the oil, because we want flow. The flow through the bearing, the flow through the sides is what cools the oil. Oil going through it makes it cool. So there's a balance there, but in general, on a steel rod, you're going to be at 2, 2.5. Mains, you're going to be at 2.5, 3. That's a good general deal. Pro modified stuff, they get real crazy and we'll get real big clearances up in that 6, 7. I've even seen stuff that was upwards of 8. But anyways, good. This is the proper way of checking your clearances. These are the clearances that you need in general for all applications. So we're going to be doing more videos. So stay tuned for other stuff. And if you have any suggestions of other things you want to see, always remember you can get a hold of us at Steve Morris Engines. And if you're a subscriber, we're more than happy to do some different videos, tech oriented, just for you.